Today we're learning a new form of equations, point-slope form. So it looks like y equals mx plus b, but it's got a little additional information. Y minus y1 equals m times x minus x1. So every equation, linear equation, needs a y and an x, or one or the other. This x1, y1 is if somebody tells me a point on the line and the slope, I can use this to write the equation. So if they give me a point, this would be x1, y1. And if they give me a slope, this is your m, your slope. So let's plug it in. So I would have y minus 3, because y minus y1 equals, the m is your slope, 3/2, times x. Now it would be minus -2. Minus negative becomes a positive. So if you write minus negative when you're working with your equation, it's going to be confusing. I would rather you write minus negative as a plus. So let's do this one here. Y minus -5 turns into y plus 5 equals the slope of 1/2 times x minus 4. Now we'll simplify these later. Right now we're just writing it. So what if I give you the equation in point-slope form and I ask you, what's the point on this line that's in the equation and what's the slope? Slope should be easy. It's the 5. It's the number in front of the parentheses. Now your x is with the x and it's the opposite because it's minus in the formula. So instead of -4, your x value is +4. And instead of meant to switch colors. Instead of +3 with the y, your y value is -3. So this line has a slope of 5 and the point 4, -3. Let's do another one. On this one, your rate of change, remember that's another word for slope, is the one attached to the parentheses. It's 1/2. And then your x value is with the x minus 6, or minus x1, x minus x1 would make this the opposite. So your x value would be -6. And then this is y minus y1. So it would be the opposite of +1, which is -1. And then if you have something in point-slope form, you want to simplify it to write it into slope-intercept form. So you've got 2 steps. Distribute through parentheses. You always do that first, and then isolate the y. So first, let's write down y minus 4, and let's distribute the 3/4. 3/4 x plus 3. You're just multiplying. Now your second step is to get rid of this -4 to isolate the y. The way you get rid of a -4 is to add it. What we do to one side, we must do to the other. And there's your equation in slope-intercept form. Let's do another one. Let's do this one where we have to distribute a -2. So y minus 11 equals -2x minus 8, because -2 times 4 is 8. And then now we add the 11, and we get that y equals -2x plus 3. So then now we have to plug into the point-slope form. And let's see, I think I'll do this one. We have to plug in. So we're going to go y minus y1 but we do minus negative, so it's the opposite. Think of it as the opposite. Changes to plus. Equals m, that's your slope, times x minus x1, which changes to plus. And now we distribute and we get y plus 4 equals 2/5 x plus 4. Take away the 4, and what happens? The constant goes away. That means you have a y-intercept of 0, and we don't need to write plus 0, so we just write y equals 2/5 x. And then now, if you're given point slope form, we can do what we did a minute ago, which is identify the slope and a point. So your x value is -4, your y value is +4, and then now we graph it by starting at the point -4, +4, and then counting your slope. It's a positive slope, so from this point, I'm going to go up 3/4, and there's my line. Let's do this one. So the slope is 5. Now, if we're trying to graph it, don't we put it over 1? 5/1. The x value is the opposite of -4, so it's +4. The y value is the opposite of 3, so it's -3. We start our graph at 4, -3, and we count up 5/1. And there's our slope. And